I know, that was a fun time.
This was taken about 8 days, maybe 6 or 7, 8 days after treatment. But I'm wearing a hat, so you can't tell I don't have any hair. I really was not expecting the words, "You have breast cancer." And at first, I couldn't even breathe. I didn't know what to say. I didn't know what to say. I didn't know what to do. I didn't know how to behave. So there was a long pause, and then she said, "Do you have any questions?"
People don't realize that breast cancer is not just one disease. We know that there are several different types of breast cancer, but it goes much deeper than that. When you start looking at the genetics, what you see is that it's a collection of many, many, many diseases.
I came to Utah because of the phenomenal genetic resources here and their strong track record in genetic research, and I thought this was would be a wonderful place to do my research.
Metastasis is important because it is the reason why cancer patients die of their disease. It's the spread of the tumor from the original site to other parts of the body. Our research focuses on how the tumor spreads to other organs, why breast cancer goes to certain organs, and what we can do to stop that process.
So there's lots of different types of cancer research, such as laboratory research, clinical research, and population research that involves studying cancer issues in communities outside of academic medical centers.
A university, a big academic medical center, despite how far along we are in the 21st century, there's still big silos, right? And there's this kind of feeling, well, I'm in this department, so I've got to be a little bit suspicious about somebody in that other department. And those silos do not exist up here. I mean, my team members are medical oncologists, radiation oncologists, plastic surgeons, my other surgeons, genetic counselors, the researchers, and pathologists, the radiologists, and we're one big group.
That we can grow and grow and grow. Freeze. It's quite unique, actually. The environments between a clinical research and a laboratory research are very difficult sometimes to meld. Here at Huntsman Cancer Institute, we have our hospital adjoined to the institute. We run into the surgeons and the medical oncologists on a very routine basis. So it's very easy to collaborate and set up meetings. We meet routinely once a month with the entire breast group. Well, we have lots of different alternatives. So the simplest way is... So one of the problems is that although there are 50 or 60 breast cancer cell lines to study, they're very poorly metastatic. So you can make tumors from those in mice, but they don't metastasize like real human breast cancer does. My idea was that if we could harvest tumors directly from patients and skip the cell culture step, put them directly into mice, they might then behave much more like the real disease. So I asked Dr. Neumeier, would it be possible to collect samples from your breast cancer patients and actually study those in a mouse model?
She said, if you can get me some tissue at a reasonable hour in the day so that we're still in the lab, or even we'll stay late if we know it's coming, but if you can get me a fresh core of tissue, and the time from when you take it out of the patient to when I get it in the lab, we can make that 30 minutes or less, which we're uniquely set up here to do, right? Because it's just across the bridge. Then we can see if we can get these to grow in mice.
So not only did the tumors grow from certain patients, but they also looked just like the tumor from that patient. We were incredibly excited about this. Not only did we have tumors that were now metastasizing so we could study that process, but they were actually connected with patients here at the Institute, which really gives us a whole new opportunity for translating our research discoveries back to the patient population.
To reach our potential in terms of genetic discoveries, we need to be able to effectively and appropriately translate genetic information to the public. And clinicians and population scientists are key players in that process.
By growing someone's tumor in a mouse, we're hoping that we can actually learn more about how that disease is going to progress, and furthermore, test therapies on a particular patient's tumor in order to help design her own therapy in a more personalized way.
I think as we get more and more personalized and understand more about patients' tumors and what genes they're expressing and what proteins they're making more of and less of, then we'll be able to tailor their treatment a little better.
I didn't even need to think twice about whether I was going to participate. And if I could help one other person, if what they learned from the study that I was in helped only one other person not to have to go through what I was going through, it was absolutely worth it.
A lot of what we do in breast cancer these days is evidence-driven. So if not for those generous women, those altruistic women who may or may not have had a benefit themselves from it, we wouldn't have the data we have now.
So what we do is we take these important genetic discoveries and find ways to bring them to the population so that we can actually have an impact on cancer and make a difference.
Everybody here at the Institute is really engaged with the mission of the Institute. We ride the elevator with patients who are going to the second floor infusion clinic. I mean, that really brings it home every day why we're doing what we're doing.
Everybody, from the person who cleans the room to the people over in the laboratory who work in the research thing, to the people who draw your blood, the x-ray techs, it comes back to that we're all working to the same goal.
I am really passionate about what we do here because I think we're making a difference. I really do. I think it's not going to happen tomorrow, but I think we're making strides that people are not making elsewhere, and that really makes me excited.
We are the only people in the United States that can do what we do and do it so well.
The dollars that the foundation raise every year help us to continue our work. Foundation dollars help us pursue novel ideas that would not otherwise be fundable, and therefore would not otherwise get done, right? And we might find the cure for breast cancer with one of these novel ideas.
We need resources to be able to do this kind of work on a larger scale. We need time to try to understand more about how this process works. And we need patients who are willing to be involved in these kinds of studies.
I feel like it takes everybody to do their little part to make it successful, and it can be breast cancer research, it can be whatever. But it takes everybody to do their little piece, and I feel like I just did my little piece.
Perhaps this can be a call to arms for all of us to rally together to help make the Huntsman Cancer Institute even better and even more successful than it is today. Because without research, we cannot find those great cures for cancer that are necessary to end this horrible disease.